Okay. Give me 1 second. Okay. Shoot, I forgot to open my drawing tablet. Give me one. It'll take like 2 seconds. Can you guys see my screen?
Yeah.
Okay. Alright, cool. So could someone tell me what they think a derivative is?
At the slope of 2 points.
The derivative is, let's say we have a function f of x. Your derivative is f prime of x is equal to, actually this is probably a bad way to say it. I'll just say it out loud. So your derivative is a function that gives you the slope of points of another function. So it's a function. It's not the slope of something. It is a function that gives you the slope of another specific function. And the way we denote a derivative, there's multiple ways to do it. One way to do it is with the prime notation, which I hate. I don't know who came up with that. Please don't use it unless you're like proving the product rule or something. That's like the only time you should ever be using the prime notation, because what it leaves out is what you guys are not understanding, which is that the derivative is change, right? It's a slope. And to have a slope, you need to have two variables, right? You need to have the change in this case, in most of your cases, you need to have the change in y over the change in x. So you need to take the derivative with respect to something. You're not just taking the derivative, period, right? You're not just taking the derivative of something. You're taking the derivative with respect to another variable. You're measuring its relationship with another variable. So the better way to denote a derivative is, in most cases, it'll be dy dx. You are measuring the change in y over the change in x. And why do we use d? It's because, what's the limit definition for a derivative, right? You have a function, and you have 2 points, and you're taking the limit of the slope between these 2 points as this point over here gets really, really close to that point, right? And so basically the d something, so dx, dy, that basically just means a really small change in x. You can think of this as a really small value of x. So like that would be dx, that really small thing over there. And so what you're doing is you're taking the really small change in y between these 2 points that are getting really, really close together, and the really small change in x, and you're getting a ratio, which is your slope, right? But the reason you're getting like an actual number out of these two small numbers, right? These are small, right? So you think, okay, your slope is going to be small, but this is a ratio, right? And because it's a ratio, you could have 0.000003 over 0.00001. I think those are the same amount of zeros. Those are really small numbers, but your ratio is 3, right? So you're actually getting the slope of the point, and that's a reasonable slope, right? So what you need to, and dy dx isn't like something special, right? If you have two different if you have two different variables that are not y or x, like a is equal to b squared, you're not going to be taking dy dx of this. You're going to be taking either the derivative of a with respect to b, where this becomes a and this becomes b, or you're taking the derivative of b with respect to a. And okay, I'll just ask you guys first, what do you think dA dB is of this?
Isn't it 2b?
Yeah, it's 2b.
2b.
And what do you think dB dA is? You're taking the change in b over the change in a. Let me think of another, while you guys are doing that, let me think of a better way to put this.
Is it 1/2 a to the power of negative 1/2?
Let me check. 1/2. Yeah, it's 1/2 a to the power negative 1/2. Because now you're measuring the change in a, or oops, you're measuring the change in b with respect. Oops, wait, give me 1 second. So that's db dA. Let me make sure I did that right. Yeah, okay, so that's dB dA. Sorry if it's a little squished. But so what I'm trying to say is uh, when you're taking the derivative, you're taking it with respect to, well, you're taking it with the consideration of two variables, right? You're measuring the change of the relation between two variables. You're not just taking the derivative of something. Let's clear this. There's another way to take derivatives, and Mr. Shao hasn't taught you this yet, but it's honestly it's just I think this will help further your understanding of derivatives, and it's honestly not too bad. All it is you can do something called the absolute derivative, where let's say we have x plus u, that's a u, plus I don't know, a plus, I don't know, give me another letter, z, plus give me one more letter, like x. Oh, I already used x. Okay, that's enough variables. But let's say that's all equal to y, right? You can do something called the absolute derivative, where give me another letter that's not all of these.
E.
E, right? And we're not talking about the natural number e, so I'll just use a capital E. I'll just name another variable e, and that's equal to whatever, it's equal to something it's equal to some relation of all these variables, right? I can take the derivative of this with respect to e. What is that? What would that be?
Wait, so you said E is...
E is just a random, I just made another variable off to the side called e, and now I'm going to take all the derivative of all of these with respect to e.
Isn't it equal to the derivative of x plus u plus a plus z?
It's not equal to the, you have to say what it's respect to, though. That's what I'm trying to get at here. So what it would be is dx, it would be the derivative of x with respect to e, plus the derivative of u with respect to e, plus the derivative of a with respect to e, plus the derivative of z with respect to e, plus, I don't know, the derivative of y with, that's equal to the derivative of y with respect to e. And then I can multiply both sides by dE, because that's essentially just a constant. That's just a really small value of e. So, or that's a really small change in e, so I can multiply those, because it's just a number by itself. And now all of these cancel out, and you get dx plus du plus dA plus dz plus dy, or is equal to dy. And that's your absolute derivative, where people will think that the absolute derivative, you're just taking the derivative with respect to nothing. That isn't correct. You're actually taking the derivative of with respect to something else and then multiplying, so you cancel that something else out.
Wait, isn't that like prove how implicit differentiation works?
Yeah, I was gonna get to implicit differentiation right after this. Let me do one more. Yeah. Actually, should I do one more? Yeah, let's do one more. Let's say y squared plus z squared plus b squared is equal to x squared, and I want to just take the absolute derivative of this. Let's name another variable. Someone give me, here, I'll erase all this. While I'm doing that, someone give me a letter that's not any of those.
D.
D? That would be, I'll do a capital D, sure. Okay, D, right? Let's take the derivative with respect to just this random variable d. So that would be 2y times, and essentially what we're doing here is the chain rule, right? We're saying, we're saying, how do I put this? We're saying that, let's make another variable. There's going to be a lot of variables with this. Let's say e is equal to u squared, right? And we want to find the derivative of e with respect, and this might get a little complicated, but follow me here. We want to take the derivative of e with respect to d, so we want to find dE dd. So what we do is, and I showed you this last time, we say u is equal to y, and we find dE du times du dy, right? And then we get, what's dE du? That's 2u times
u. Or u prime.
times du d. Wait. So it's du 2u times du dy. Actually, here, let me backtrack a little bit.
Isn't it du de?
Well, we know what ded. Well, here, let me backtrack. I think I'm getting a little lost here. Let me backtrack.
DE divided by DU is 2U, right?
DE divided by du is 2u. Yeah, it is.
Yeah.
I just wanted to. Essentially, what we're doing here is the chain rule, where we take the derivative of the outside function, 2y, and then we take the derivative of the inside, y, with respect to d, which is just dy dd, right? Plus, and then I would do the same for all of these. I wasn't really that creative, but we do the same, right? And I should probably have left more space there, but I'll squeeze it in there. Oops. And that's all equal to 2x times dx dd. And I just took the derivative with respect to some random variable. But all these terms are over dd. So what I can do is multiply both sides by dd. Cancel them out. So I get 2y dy plus 2z dz plus 2b db is equal to 2x dx. And that's what people call the absolute derivative. Most teachers will say, you're taking the derivative with respect to nothing, but you're actually taking the derivative with respect to some random variable and then canceling it out. And so what I was trying to get to with all of that was you have to take the derivative with respect to something. You're not just taking the derivative, you're taking it with respect to something.
Wait, but what would happen if you're taking like the derivative of a derivative? So let's say you take the derivative of dd.
Well, the derivative with, actually, yeah, give me an example.
X cubed plus 3xy plus y squared is equal to 5.
And you want to take,
Yeah,
the derivative twice?
9. Yeah.
Well, I mean, so you would do 3x. Wait, what are we taking the derivative with respect to? That's what I'm trying to get at. Whenever you ask to take the derivative, you should say what with respect to what. Because right now I don't know.
Okay. Well, it's not really. It's supposed to be implicit differential. So you just
Implicit differentiation, but we're still finding dy dx. It's the only reason it's implicit is because we have all these y's that we need to also take the derivative of implicitly. We could do the absolute derivative of this, which, you know what, I'll do that too. Right now I'll do it implicitly like you're saying. Let me do that. So what we're doing is here, we're taking the derivative with respect to x. So we're taking, and that's where the third notation comes in. Mr. Shao probably showed you d dx. Did he show you that?
No.
Okay, well there's a third notation.
I mean, isn't the difference between dx and like dy by dx, like one of them is when there's like an equation in place and they're trying to solve for something, and one is just like
The difference between them is if you have a single variable on one side, you can say dy dx. Actually, that's all. The only reason this exists is if you have like a jumble of all these variables and you want to take the derivative with respect to x of all of these variables, then you would just say d dx. And so we want to find d dx of this. So we're still finding the derivative with respect to x here, right? That's the only reason he calls it implicit differentiation, because there's these y's that you have to implicitly differentiate. So what's 3x? So that would be 3x squared times dx over dx, which cancels out to 1. Does that make sense? Why it's dx over dx?
Oh, so that's why we don't put x
Wait.
prime.
Yeah.
Or,
Why is it?
Yeah. See, that's why the
Why is
prime
it
notation is so stupid because everyone gets messed up. They don't know what prime actually means, so they just use it, and it's wrong. That's why this notation is so beautiful, right?
Wait. Can you repeat what you just said, like really quickly? Sorry.
Okay. Well, so it's 3x squared times the derivative inside with respect to x, dx. That cancels out. That's 1. It's because we're taking the derivative with respect to x that it cancels out, and that's why there's nothing there.
Wait, for the next one, would it be dx dy over dx? Then?
For this one over here,
The 3x one.
that would be product rule. I'm not sure what it is yet. I'll have to do it. Because there's two variables.
Yeah.
Yeah.
Okay.
So, anyways, this is the most important part that Mr. Shao doesn't directly tell you. But like, if you understand like this, then you get most of derivatives in general, actually. So does that make sense?
Yeah.
It only cancels out. What were you gonna say?
The derivative of x cubed in respect to x.
Yeah. And most people would just say, okay, we're doing it with respect to x, so it's just 3x squared. But the reason there's nothing extra is because it's the chain rule, right? You're taking the derivative of the outside and then the inside. What's the derivative of x with respect to x? Well, it's dx over dx, just like how the derivative of y is dy over dx. This is dx over dx. And it cancels out to become 1. Does that make sense?
Wait, can you repeat that?
So, you know how... So, let's just implicitly differentiate y cubed. What is that?
3y squared.
3y squared. Oh, you know what? I just fell into my own trap. Let's implicitly differentiate y cubed with respect to x. So what would that be?
Be 3y squared times y prime.
I wouldn't use prime notation.
Or dy over dx.
Yeah. Because the derivative of y, the derivative of the inside, this is all just chain rule essentially. The derivative of the inside is dy dx. Right? The derivative of y with respect to x is dy dx. So similarly, this is 3x squared times the derivative of the inside, dx dx. Right?
Wait, why are you taking the derivative with respect to x?
That's what Mr. Shao wants you to do right now. That's why. If you see in the top of your paper, it should say find the derivative with respect to x or find dy dx or something like that on the top of your worksheet.
What is the difference between d over dx and dy over dx?
So dy over dx is essentially when we want to find the derivative of a single variable. So like let's say we have y and u and z, right? If I want to find dy dx, these would just be treated as constants and they would actually go away, I think. I haven't thought about that much, but these would essentially go away and become constants, right? If I wanted to find dy dx. So that's why d over dx exists, where I'm saying let's take the derivative of every variable with respect to x. So now it becomes dy over dx plus du over dx plus dz over dx. Does that make sense?
How come we're not taking the derivative in respect to dy?
You can. The only reason you aren't is because Mr. Shao isn't giving you questions to do it that way. Like, let's say x is equal to y cubed, and I want to find dx dy. Well, that would just be 3y squared times dy dy. So it cancels out, become 1.
Okay, so I think technically there is a question like that in the packet where he asked like to use a chain rule to find d2y given that y is equal to cosine 3x.
Okay, can we come back to that problem and like once I finish this, I want to come back to that problem. So keep that in your mind and remind me.
Yeah, of course.
So does that make sense? You can take the derivative with respect to anything. And this is why This is why calculus is more of a practical math than you are used to, because you'll start doing practical applications like launching a missile and seeing how far away it lands and stuff like that, because you get to take the derivative with respect to a variable, and that gives you useful information about that variable, about that whole expression related to that variable.
Yeah,
And so
I have a really dumb question. Okay, like if we're taking like dA over dx for y plus u plus z, right?
Okay,
It's just a constant, right?
Yeah. So it would become, what's the derivative of constant? 1?
Yeah.
Yeah, it would just become 1.
All right. Thank
Wait.
Wait,
So-
derivative of constant is 0, right?
0.
Yeah.
Yeah, okay, that's my bad. Yeah, 0, because constants don't change, right?
Wait, but why are those variables considered constants?
Because we're not finding the derivative, we're not finding the change with respect to them, right? Now, here's the thing. If, let's go back to that actually. dA over dx, is that what you said? Of like, what was on the inside? Like
just
u?
like y plus u plus z.
Okay. Well, let's put a x. Yeah, let's put an x here. X plus y plus z, right? If these were somehow related to x, if they changed also with respect to x, like let's say y was equal to 3x, then we would have to take the derivative of these. So it would, let's say they also told you y was equal to 3x, right? You would take dx over, or oops, my bad. You would take, this becomes 1, right? Plus, and we want to find dA over dx. We have y, so we want to find, what can we multiply to cross out and make dA over dx? If we have, wait.
dx over dy.
So if we have dy over dx times what is equal to dA over dx?
dA over dy.
Yeah. So dA over dy. And what's the derivative of, and so what's the derivative of this with respect to y?
1.
1 times dy over dx. What's dy over dx?
dy over dx.
Of this
Isn't it
expression.
3?
Yeah, so it becomes 3. And that's basically the same thing. That's a really long way of saying, like, another way you could have done that. That's a lot simpler. I just wanted to do it this way because it shows you what a derivative means. You could literally just plug this in and say x plus 3x, and then it would become 1 plus 3, right? But you see how that's the same thing? And then,
Yeah.
and then at the end, keep going.
So if it's not given like to respect, then it's just treated like a constant. So if
it's not, if
y was not equal.
Yeah, if y, and generally they'll tell you this in the question as well, but generally if you don't see a relation with y, like if you don't see that y is related to x in any way, then you treat it like a constant. And that's why you'll see some questions say treat k as a constant or something, right? Because you're essentially saying there's no relation, right? Y could be equal to 3u, right? But we would still treat this as a constant because it has no relation to x. It has no relation to what we want.
Alright, so if y was not equal to 3x, it'd just be 1 plus 0.
1 plus, no, it would be 1 plus, 1 plus 0. You're right.
Alright.
So it's really, really important that you know what you're taking the derivative with respect to. I hope you guys see that, because that was why I went on that whole spiel, was to show that it's really important that you know what you're taking the derivative with respect to. And that's the heart of implicit differentiation as well, is that you're taking, and Derek, could you confirm for me, either next to the questions or at the top of your worksheet, it should say find dy dx, right?
Yeah.
Yeah. See, that's why these cancel out, and that's why those cancel out, and the y's don't, because we're finding dy dx specifically. That's why he has to say that. He's not saying implicitly differentiate this. He's not saying that because that makes no sense. We don't know what we're doing it with respect to. He's saying dy dx, and implicit differentiation is just a method to find it. Does that make sense?
Yeah. When he explained it, he didn't like take the derivative of both sides.
Yeah, and it's a little tough because yeah. Like Mr. Shaw is a great teacher, but he also like you have to take your own initiative to find this stuff. Like I mostly came across this just by asking questions, right? I was like, why the heck does X's cancel out? I would go online, search it, and then I would figure it out. And then Mr. Shaw makes more sense. But if you're not doing that on your own, it does. Mr. Shaw can. I admit that he can like not make sense sometimes, or he can not just not make sense. He can be like a little incorrect or a bit misleading. Okay, so I think that's all I have to talk about with respect stuff. Um yeah, I think that's all. So we can start doing implicit differentiation. So I think Shrieker, you had a problem. Let's do that one before we do like some regular ones.
Yeah, so I think it was just like relating to this, but the question was use the chain rule to find I'm not sure. Yeah, use chain rule to find. I'm not sure how you use a notation for this. I mean, how you see the notation, but like d of t y.
Wait, just say the letters out so I can write it.
Right. Yeah, it's capital D, and then subscript t, and then like y.
Like this?
No, like lowercase y. Sorry. Yeah, exactly like that.
Okay, so this is another notation. There's a lot of notations. I forget what exactly because no one uses this notation usually. I think it's the derivative of t with respect to y. That's what that means.
Yeah.
Yeah, it's just I actually have no clue why this notation exists.
Wait, isn't it the other way around? Isn't it the d
Oh,
of
yeah,
y
yeah.
with respect to t?
Are you sure about that? I mean,
Yeah,
I
I'm
might
pretty
be
sure
wrong.
the subscript one is on the bottom.
Okay, well, I don't know. I never use this notation. This is probably, apart from the prime notation, this is probably the most useless notation there is. But yeah. So that's something.
Okay.
All right, just
This
keep
is
going.
given.
So let me wait.
This
Give me
is
1 second. Okay, so I'm just gonna so dy dt. Okay, and what were you saying?
Alright, so this is given that y is equal to cosine of 3x,
Okay.
and x is equal to 10t.
Okay, so there's multiple ways to do this. Well, there's two ways to do this. You know how I showed you how you can just straight up plug it in, right?
Yeah,
So there's two
it
ways.
says to use chain rule.
Yeah, but the other way to do it is we want dy dt, right? And we have yx, so we can take dy dx in that expression, and we know what x is like in relation to t, so we can also take dx dt. And it just so happens that these cancel out perfectly. Sometimes he might give you even more expressions that are completely red herring and useless, and you have to find which ones to correctly multiply together. But in this case, you see how they just cancel out. So let's find dy dx. What's dy dx?
Is negative sine 3x times 3.
It's negative sine 3x times 3 dx dx, which cancels out to become 1. Right? I'm just doing this for show, by the way, just so you guys like get that in your head. But yeah, anyways, so that's dy dx. Now we want dx dt. What's dx dt?
10.
10 times dt dt,
Yeah.
which becomes 1. Right? So that's 10. So it's 10 times whatever this is, right? 10 times negative 3 sine 3x. So negative 30 sine 3x. dy dt, and that's dy dt. So that's what he wanted. I guess that's a challenge problem, and this is probably where I learned it. He probably went over the challenge problem in class, and showed us how it works. But you see how everything's founded on the chain rule? All we're doing essentially here is a chain rule, right? We're taking dx dt, right? That's the derivative of the outside, which is 1, times the derivative of the inside, which is dx dt, right? And then here we're taking the derivative of the outside, which is 10, times the derivative of the inside, which is dt dt. Essentially, it's all just chain rule, right? Okay,
Yeah.
so
Wouldn't we substitute x for 10t? So wouldn't it be negative?
Yeah.
substitute x for 10t, where?
Yeah, on the bottom where's dy in terms of dt, it would, instead of negative 30 sine 3x, it would be negative 30 sine 30t because
Oh yeah,
x
yeah,
is in
yeah.
terms
That's
t
that's
not
right. That's right.
x, right?
Mm-hmm. So yeah, because otherwise, if I put x here, it's kind of useless. So you need to say with respect to t. That's right.
Yeah.
Okay.
Wait,
That's
actually, because like I'm pretty sure in like Shaw's answer key, he just left it as that.
Yeah, it's
He
good
did?
practice to do this though. It's good practice to turn it back into the
Alright.
variable that you're taking with respect to.
Yeah. Bobby, I think in the answer key it still says 30t inside.
Alright.
Or whatever. Yeah.
Okay. So that's
I did have another question.
Yeah.
Oh, yeah, sorry.
Wait. So does this make sense to everyone? And then you can verify your answer by let's plug this in, right? So we get y is equal to cosine 30t, and then we find dy dt, which is negative 30 sine 30t times dt dt, which cancels out to 1. So you can verify your answer that way. And this is the heart of differentiation. Like that's if you're gonna come away with anything about derivatives, this is the most important. Well, this and whatever I showed you last time or whatever I showed you like 5 minutes before that I just erased. That's the most important part about differentiation. Because once you get to word problems where like you have a ladder and it's falling down and how far is it going outwards against the ground, you'll be having all these variables, and it's usually a unit that people have a lot of trouble on because what they learn to do is to just take the derivative with respect to nothing. They just take the derivative because they take the derivative, or you know what I'm trying to say. So but if you understand this becomes very easy. The application becomes pretty easy.
Wait,
Alright,
so
I did have another question. Oh, go ahead, sorry.
Yeah, let's do
how would
Derek's question first.
taking a derivative of a derivative work?
Um,
Nothing.
let's do a problem. It works pretty much the same, but we can do a problem. Let's just do one problem to make sure I'm not missing anything about that. So, is there a problem in your?
Yeah. X cubed plus 3xy
Oh
plus
right, I
y
remember.
squared equal to 5. Yeah.
And we're taking the derivative with respect to what?
With respect to x.
Okay, so we're finding dx. Yeah. Okay. And here I could actually say, yeah. So we're finding dx, and wait. Give me 1 second. What? 1 second to think about this. Yeah, we're taking d dx. I don't know if I want to use dy dx notation here. I'm trying to think if it's acceptable to put that over there. Yeah, I think it's acceptable because there's only two variables. So you could say d dx or dy dx because there's only two variables here. There's not more. So anyways, all right, dy dx. So 3x squared times dx dx plus this is the product, so 3x and y. So the derivative of the first is 3 times dx dx. So derivative first times the second plus the derivative of the second, dy dx, times the first. And then plus the derivative of the outside, this is chain rule 2y times d 2y times d 2y times dy dx. And that's equal to 0. Because constants don't change no matter what. So the derivative of phi with respect to no matter what is always 0. And okay, and we want to find what are we finding here actually?
We're trying to find y prime,
Y
and it's
prime?
given that
Or
x
not
is
y prime,
1,
dy
y is
dx.
1.
What did you say?
Yeah. We're trying to find out y prime,
What did you say
and
after that?
then it's given that the point is 1, 1.
Okay, so we have a
Point
point
x.
1 1. Okay, let's just keep that in our minds for now. And these cancel out to 1. Here, let me do this in a different color. So these cancel out to 1. That cancels out to 1. Does anything else cancel out? No. Okay, so it becomes 3x squared plus 3y plus 3x dy dx plus 2y dy dx is equal to 0, right? Now we can move these terms because they don't have any dy dx onto that side. So 3x dy dx plus 2y dy dx is equal to minus 3x squared minus 3y. And then we factor out dy dx. And then we divide. So we get dy dx is equal to 3x plus... Oh, you know what we're finding? We're finding the slope of the point at 1, 1 of this expression. We're finding the slope at 1, 1 of this expression, right? And since this slope is in the coordinates x, y, we have to find dy dx in order to find the slope. Okay, so now we minus 3x squared minus 3y over 3x plus 2y. We plug in this point, so minus 3 over 3 plus 2. So that's negative 6 over 5. That's the slope of that point of this in this expression. Does that make sense?
Yeah.
And here's how I write it out. Dy dx of 1 comma 1 is equal to 6 comma 5. That's how I would write out your answer.
Okay, gotcha. And then how do you find the derivative? Because it's asking for a y double prime.
Okay, so the way you write it in this notation, and I'm actually not 100% sure why, it's d squared y over dx squared. I remember I had a good explanation for that, but I think I forgot it. Give me 1 second. I'm trying to remember. The only good, yeah, I don't have a good explanation for that actually. Yeah, you just put the squared up here for some reason, but okay, so that's what we're trying to find, right? Wait, are we supposed to find d squared y dx squared at 1 comma 1? Is that what we're finding?
It says to find y double prime. So like the derivative of y prime.
So what the derivative? Yeah. So we're trying to find y double prime. What was this point for then?
To find y prime.
So that was a separate problem, and it's like an
No,
A-B
it's the
situation.
same problem. Same problem.
Is it like an A-B situation?
Yeah, it's the B part.
Yeah.
Okay, that's what okay, yeah. So now we can find, could someone tell me what that is? Write that down and tell me what that is, because I'm going to erase everything. Actually, I don't need to erase. I'll just keep that one part. I'll erase everything else. Okay, so dy dx is equal to negative 3x squared minus 3y over 3x plus 2y. And we want to find d squared y over dx squared. So what we do is, so what we would do here is, it's a quotient, right? That's all it is. So we would take the derivative of the top, which is negative 6x times dx dx minus 3 dy dx. The derivative of top times the bottom, 3x plus 2y, minus the derivative of bottom, 3 dx dx plus 2 dy dx times the top, all over the bottom squared, 3x plus 2y squared. And these cancel out. These cancel out to 1. These cancel out to 1. Okay. So and then what you would do, so I'm not going to do this whole problem. Can you tell me in his answers if he has dy dx in his answer? Because he might want us to plug this back in, which I'm not going to do because that's going to be really annoying.
No, he does not.
He doesn't? Okay, so what you'd have to do, and I'm not going to do this because it's just kind of unnecessary work, but you see how now I this is the double derivative right here, and I have dy dx in it. I would take that and plug it back in, and then simplify it.
Wait, where'd you get the times dy over dx from?
Where?
From 3, so 3 times dy over dx.
Because it's 3y. So the derivative at the top with respect to x. So the derivative
Oh,
of,
okay, gotcha.
yeah, with respect to x. So it's negative 6x times dx minus 3 dy dx.
Wait, so you plug dy dx into the equation? And...
Yeah, you'd plug dy dx into all of these, all of them, and then simplify.
Oh, okay.
Yeah, it's a lot of work. I don't.
No, because we already solved for dy dx. We said it's equal to negative 6 over 5.
Oh,
I was
right.
getting this out.
Oh, right. Okay, so actually, yeah, that's actually, yeah, that's smart. And you know why that works? Actually, I mean, it works. So we're finding we're finding the derivative of this at that point too, right? Because otherwise it wouldn't work if we weren't finding this at the point 1, comma 1. So I'm assuming in the question it's asking you to find the second derivative at this point as well. Is that correct?
Yeah.
Okay, so that's why
Right.
you can just plug it back in, because essentially you're going to have to do that anyways, right?
Yeah. But well, what does the second derivative represent? Because if the first one's the slope, what's the second?
It's the change in slope. So you'll do this later in calc, but let's say we have, let me think about this before I draw it.
Shia gave us a good example. It was like
Here, let's say we have
Oh.
this, right? Or, yeah, you keep going, Avi.
it's like a velocity, and then it becomes acceleration because
Yeah.
like change in velocity is acceleration.
Yeah, it's
Like,
essentially,
based on that.
Oh, okay.
yeah, but
Yeah,
I mean,
makes sense.
graphically, it would look like, you see how the slopes, oops, that's not a good color. You see how the slopes are positive here? The tangent lines are positive, right? But over time, they're decreasing, even though they're still positive. That would be your second derivative. It would be negative because it's decreasing. Your change in your slopes is decreasing. Does that make sense?
Oh.
The change in
okay,
the
that
slope
makes sense,
is your
yeah.
second derivative. And that's also acceleration, right? You could be moving this way, but you could also be decelerating because your velocity is changing. So, and then after second derivative, it really doesn't make much sense. So once you start graphing, like what you'll do with all this second derivative stuff is you'll start graphing functions more accurately using all this information. And once you take like the third derivative, it really becomes meaningless. So you only really take 2.
Alright. Wait, can you keep this up for a little bit? I'm just gonna copy it down.
Okay, I can keep it up. But the only reason, so if it was, so let's say A, right, told you to find the derivative at that point, but B told you just to find the second derivative in general, you wouldn't be able to plug in the point here and then plug it in. You would have to plug in this expression into it, because that slope only applies to that point. Does that make sense?
Wait, could you say that again?
So you know how the second part of your question, B, tells you to find the double derivative at that point? That's the only reason you're allowed to put negative 6/5 into here. Otherwise, you'd have to put this instead if it told you just to find the second derivative in general.
Oh, yeah.
I have another implicit differentiation question.
Okay. Okay. What else is? I just need to ask. What else is on your? What else is on your test? Is it just implicit?
No. Most of it is just like normal derivatives. It's like we only have implicit because our test is on block day for this, but like
I mean, it's pretty much just chain rule.
Yeah,
chain
implicit.
rule, product rule, quotient rule,
Yeah,
and then the application like lines, I guess, the
Yeah,
tangent
okay.
lines and
And-
normal line.
And do you guys understand that implicit is essentially just a chain rule? It's not a separate thing, right? You're not really ever implicitly differentiating something. You're just doing the chain rule to it, right? Does that make sense?
Wait, what do you mean?
So like, you see how implicit differentiation essentially just becomes a chain rule, right? dy dx and the dx dx, right? So all I was trying to say there is that implicit differentiation is you really don't use that term much because it's only specific to, let's say you have x, you have two variables and you're trying to find the derivative of a whole expression with those two variables. Actually, you know what? You can just forget that. It makes a little bit of sense, but honestly, you probably don't need to know that. All I was trying to say is like the implicit differentiation is essentially just the chain rule. It's nothing special, is what I was trying to say.
Okay.
Does that make sense? Why it's just a chain rule? Because I think I showed you guys that before I did this problem.
Yeah. Wait. Isn't it just yeah? Because it's like the single variable. You're basically just taking it. You're making a separate variable, and then taking the derivative with respect to the variable you made.
Well, yeah, that's called absolute differentiation, where you're just taking the derivative of everything. Implicit is when you're taking the derivative of, let's say, dy. Let's say you're taking the derivative of something that's in your expression, but there's also other variables in there. Then you'd have to do implicit differentiation. So what you said was absolute. This is implicit because you have some stuff that you can easily do, and you have some stuff that you also have to do implicitly. So it's a mix. Does that make sense? Actually, yeah. Does that make sense? I'm trying to find a better way to explain it, but does that make sense? The thing I showed you with the whole extra random variable, that's absolute because nothing ever cancels out, right?
Yeah.
But then since
then
it cancels out, it's implicit.
So implicit, it's basically just taking the derivative of a variable that's already in the equation.
Yes, yeah,
with
that's
respect
what
to
I was trying to say. Yep, that's exactly right.
Okay, gotcha.
But it all can be under just the chain rule. Like it's nothing like specifically special. It's all just the chain rule at the end of the day. Do you guys understand why it's a chain rule?
Yeah. Because it's basically just taking it with the respective to the derivative.
Yeah, you're
already in
essentially
the
taking the derivative of the outside function times the derivative of the inside function, and sometimes that cancels out, sometimes it doesn't.
Okay, gotcha.
Okay, I think someone else had another question. I can go until like 5:40, and then I gotta go do my math homework because I have a math test tomorrow.
6
So, any last questions? I can go for like maybe 15 more minutes, so I can do like 3 or 4 more questions.
My question was cotangent for y.
Actually, wait, before you say that, Derek, are you done copying it down so I can erase it?
Yeah, you can erase it.
Okay. All right, you can say, actually, let me finish erasing and then you can say your thing. Okay, say your question.
Cotangent 4y squared equals cotangent.
Equals cotangent? Cotangent of what?
No, cotangent 4y squared. Not tangent.
Oh, wait. Okay, wait. Okay, so cotangent 4y squared. And what are we doing? Oh, equals, okay.
X times square root power 8 at 0.0 comma square root power 8.
And what are we taking the derivative with respect to?
Dy over dx. And by the way, it's square root power 8 for the point.
Oh, wait. For the point, it's square root pi over 8 or square root pi over 8? Like, is it just, which is square rooted? Just the pi or both?
Whole
pi?
square.
Okay, whole square. So is this correct? Or am I missing anything? Oh, I'm missing one thing. Okay, now is it correct? Okay. So this term over here would just be the derivative of the outside chain rule. And I wanted to let me use this as a chance to Actually, never mind. So it's the derivative of the outside. It's the derivative of the outside with. Here, let me do this with fractions. I wanted to do it with fractions earlier. I just wasn't able to do it. Let me try doing it with fractions now. So, let's say cotangent, u is equal to, or y is, shoot. Okay, u is equal to cotangent 4y squared. And then, and if this doesn't work out, I'll show you guys later. Once I figure it out, this is just, I'm just doing like a little experiment right now, trying to show implicit differentiation with fractions like I did with the chain rule, just seeing if it works. So u is equal to cotangent a, and let's say a is equal to 4y squared, and we want to find dy dx, and we have du dA times dA dx, get du over dx. Yeah, it doesn't work. I'll figure out why it doesn't work, but for now, just like use the chain rule like I showed you that one time, which is, derivative of the outside, cotangent 4y squared, times the derivative of the inside, 8y, times the derivative of the innermost, which is dy dx. And that's that, and that's equal to square root pi over 8 times dx dx. Okay, let's see what cancels out. I think it's just that. So you get square root pi over 8 is equal to dy dx times 8y.
Wait, why don't we find the derivative of square root pi over 8?
Because that's just a constant. A constant times x. Let's say y is equal to 8x. Y is equal to 8x, right? Dy dx would just be 8. The constant, well, it would be 8 times dx dx. The constants just stay. The coefficients that are constants just stay. I'm trying to remember why, but they just stay. Does that make sense? It's just a constant, right? This is just a number. I could replace it with 2.
Okay. And then shouldn't it be negative cosecant squared 4y squared?
Yeah, it should be. Let me do that. Negative cosecant squared. Okay, there it is. Actually, here's a better way to explain this. I just figured it out. You know why coefficients stay? It's because, let's say y is equal to 8x, right? I could say y is equal to x. Actually, let me do less.
Isn't it just product rule?
It is product rule. Yeah, I was gonna say one could be the product rule. You can try that for yourselves. Another way, let's say y is equal to 2x. Y is equal to x plus x. Dy dx is equal to dx plus dx dx. Those cancels out, so it's just 2. Yeah. So that's there's multiple ways to prove that this is that works. So anyways, let me keep doing this. Cosecant squared 4y squared times dy dx. Now we can plug in this point to find the slope at that point. So that would be negative 8 square root pi over 8 cosecant squared 4 times pi over 8, which is pi over 2, times dy dx is equal to square root pi over 8. And I can cancel these two out. And then I can, what's cosecant squared pi over 2? That's 1 over sine squared pi over 2, so it's just 1. So let me do that in red. So that becomes 1. So it becomes negative 8 times dy dx is equal to 1. Oh, and that becomes 1. So that's equal to 1. So dy dx is equal to 1, negative 1/8. Any more questions? Is that?
Wait, I have one more question.
Yeah. Okay.
Alright, I'll post it in. It's kind of hard to explain. I'll
Alright,
post it in the chat.
Okay, where are you posting it? Let me see. Do it in the homework help section. The session dates is already messy as hell. Also, since I'm recording these, it was a good idea that whoever asked me to record these told me to do that, because I'm thinking now I could just do all these on Discord. I don't need to do them on Schoolhouse anymore, and I'll just keep these videos in a log so I can prove my service hours that way instead. So yeah, forget Schoolhouse. I'll just do it on Discord.
I posted it. I just wanted to figure out how to do 1B.
Okay,
Where I forgot. I know how to do 1A.
I don't see it though.
Okay.
Where'd you post it?
I posted it in the homework help section.
I do not see it. Is there a reason?
Derek, isn't
let
it
me
just
try.
an inequality? Isn't it just an inequality?
Hold the phone. I cannot see it. Why is that? Could you post it in session dates? I have no clue why I can't see it.
Wait, what do you mean by inequality?
Because when f is like f is increasing, basically it means that let me pull it up. Wait, so what did you get in the first part? What was your answer? It was
I got
0,
2 in that.
yeah, right. So
And
it
2
was
negative
12x squared minus 24x equals 0, right? Was that one of the steps?
Wait. Oh, I know that.
I put it in the chat, by the way.
12x squared. Yeah.
Yeah. So
Wait, is it in homework help? Because here, I'll show you guys what I'm seeing. I'm seeing nothing in homework help.
oh yeah, I'm not seeing anything either now.
I put it in this college chat, like on the
Do you see it in general?
There is no general. There is session dates.
Oh wait, I'm pushing it.
Oh,
Okay,
he puts
wait,
in
I
their
got
answer.
it.
Yeah, I
posted
was
the-
confused for
yeah.
a second.
Okay,
I
wait,
got
Derek.
you.
So if the function is increasing, it means that the derivative is positive, basically.
Well, be careful with your definition of increasing, because I showed you with double derivatives.
Yeah.
Actually, yeah, just understand what increasing means. Increasing just means that it's going up. So even if it looks like this is technically increasing.
Mm-hmm.
That's all. Yeah. Just like be careful of your use of increasing.
So if it's positive, then like it has to be positive, right?
Okay, what number?
So then 1b.
Okay.
So then just set 12x squared minus 24x.
Here, I'll do it actually.
Yeah.
This is there's one way to easily do this that he shows you later, which is what I call a y prime line. That's the only time I ever acknowledge prime notation. X, is that an x squared? 12x squared? Yeah. Okay, 12x squared plus 2. Okay, so dy dx is equal to 12x minus 24. Oops, it's not 12x at all. 12x squared minus 24x, right? Factor out an x, set that equal to 0, because think about it, right? This is a continuous function, correct?
Yeah.
So that means for it to go from negative to positive, this is where IVT comes in, right? It has to be 0. So what you do is you set it equal to 0. And where is that equal to 0? I'll put 12 on the outside, x minus 2. So it's equal to 0 at 0 and 2. Now to check, right, let's make a y prime line. Plug in a number between 0 and 2, 1, into dy dx. What is dy dx at x equals 1? Is that negative or positive?
Yeah,
negative. And then, I mean, we know, I think you guys did this in pre-calc, right? It alternates.
Yeah.
So it goes from positive to negative to positive. That's kind of what the graph looks like. Does that make sense? Because the slope is negative here, it's positive here, it's positive there. and you can
Yeah.
see it's you can also see it's 0 here, 0 there. Okay, so
But
So-
how do you know if what the y values are based on the slope?
you don't. you
So how do
can't
you know this?
you can't tell whether it's positive or negative. This is just a y prime line, right? Oh,
Yeah.
I see what you mean. I see what you mean. So if it's increasing, it looks like this. If it's 0, it's flat, and then if it's negative, it goes down. So I know it has to follow this general curve, right?
Yeah.
And then here I know it has to follow. This is by no means what the actual graph might look like. This hump might be way higher. This hump might be less high. I have no clue about any of that. All I'm doing is drawing like a general graph. Does that make sense? I'm not actually predicting. Well, I'm kind of predicting, but I'm not actually showing what it looks like.
Yeah.
And I'm not also, and yeah. So, does that answer your question? I could go into a little more detail, but Mr. Shao does it with you anyways.
I'm just confused at like how do you know like because it asks like what are the intervals in which like the point is like negative, or is it the slope is negative?
Yeah, slope is. It might be asking where the. No, it's asking where the function is increasing. When is it increasing? When the slope is positive.
Oh, okay,
Yeah.
I got you. Thank you.
So, or when the first derivative is positive. When the second derivative is positive, that doesn't necessarily mean it's increasing. It could look like this, right? Where the slope is technically negative, but the second derivative is increasing, but it's still decreasing overall. But anyways, yeah, so this is the one region where it's negative. I think, oh wait, it's asking when it's increasing. My bad. Here's the regions where it's positive. So it's when x is, what, greater than 2? And why is it not equal to? Does anyone know why?
Because if it was
it's horizontal.
Yeah, it's horizontal. It's neither increasing nor decreasing at that point. Okay, I have a question for you guys. If the derivative is 0, does that mean the double derivative is 0?
If the derivative of what is 0?
Of a function is 0. Does that mean the double derivative is 0?
Not necessarily.
Yeah.
Because if it's 0 at like one point, it could be like a different slope at another point, right?
Yeah. Essentially, it's because so here you see the derivative is 0, right? But if you look at the overall trend, your slope is technically decreasing. So your double derivative at this point would actually be a negative number. It wouldn't be 0.
Oh, what? Oh.
Wait, what? But then at that point, isn't it neither decreasing or increasing?
Well, the slope is, but the double derivative does not dictate increasing or decreasing. All it does is all it does is dictate the shape of. Actually, I don't want to say shape of your curve. It just dictates whether the slope is increasing or decreasing. So if you have a pump like that, right, your slope may be 0 here, right? But look, it goes from a positive number over here to 0 to a negative number, right? So your slope is decreasing. Your slopes are decreasing. Actually, how do I say this? Your slopes are decreasing.
But don't you find the slope at like a specific point is 0, and then wouldn't you use the same point?
So wait. So the slope goes from positive to negative, right?
Yeah.
But if the slope goes from positive to negative, so let me make a graph. Let's call this y prime, another rare case of the prime notation actually being useful. So, it goes from increasing. Wait, how do I? So it goes from. Shoot, give me 1 second. So if it's going from positive to negative, you see how the slope here went from positive to negative?
Yeah.
If it goes from positive to negative, look at the derivative of your slope. Look at y double prime. The derivative of this derivative, or the slope of this derivative. It's negative. Do you see that?
Yeah.
So y double prime is negative. Y double prime can be negative or positive when y prime is 0, right? It could also be positive here. That's all I'm trying to say. Wait, does that make sense? Do you have questions?
Kind of dodgy.
Wait, so I thought.
Let me think of a better way of explaining this. Okay, so you see how I'm drawing all these tangent lines? Let's say it's the slope of this one, the leftmost one is 1. Then let's say it's 0.1. Then let's say it's negative 0.1. Then let's say it's negative 1, right?
Mm-hmm.
Yeah.
And then over here it's 0, right? Over there it is 0, right? And let me turn this into a y graph, not a y prime graph, right? So this is the graph of some function, right? Let me clean this up to make the explanation go. Okay, so that's the graph of some function, right? Do you see how what is y prime at this point? What's the derivative at this point?
0.
0, right? But what is the double derivative? It's the change in your slope, right?
Oh, okay,
So your
I got
slope
you.
is going negative. It's decreasing. Your slopes are decreasing.
Yeah.
It goes from up. It's going from 1 to 0.1 to 0 to negative, right? So your slopes are decreasing. You guys, that makes sense, right? Your slope is decreasing.
Yeah.
But your
So what would
function,
it be? What would the final answer be? Like negative 0.1?
or what final answer of what? Like y double
Y
prime?
double prime.
It
Yeah.
would be just some negative number. I'm not sure what, because I don't know how fast the slope is decreasing, but it's some negative number, right?
Okay.
Okay, that makes sense.
Yeah, that makes sense.
So if it was like the parabola was facing upside, then it would be positive, right?
Yeah, and actually that's another way you can prove, instead of drawing a y prime line, that's another way you can prove that it's what we call a relative maximum or a relative minimum, is by finding the double derivative at that point and seeing whether it's positive or negative.
Oh.
So double derivatives don't dictate increasing or decreasing. They just dictate the change in your slope. But your slope dictates whether it's increasing or decreasing. And that doesn't have to make sense right now, because you guys will be doing that probably way later in the year, maybe halfway into the year. So I don't want to go too deep into this. Where were we? What was yeah? So that's how I know. That's how I know this has to go. This has to go. That the graph has to kind of look like this. Not exactly, but it has to kind of look like this, because it goes from a positive to a negative slope. So it has to be, and we know it's 0 over here. So it has to look like that. That's what I was trying to say. Does that make sense? It might be a little dodgy. I can explain it better once you guys get later in the year. Does that make sense?
Yeah.
A little? Okay. Do you guys have any last questions? Because I gotta go in like 5 minutes.
Wait, so the graph of so y double prime would be the graph of y prime,
Yeah.
right? Would have
Or
the slope of
yeah, the slope of y prime. The change
Okay.
in your y prime.
So that would just be like a line with a negative slope going down, right?
Where?
The graph of double prime.
Yeah, it would be a negative. It would be a negative value. It wouldn't
Yeah.
actually, not your slope is, so let's say y looks like this, right? That's y.
Yeah.
Y prime would probably look like, here it's 0, right? Here it's 0. Let's just call that 2, right? So y prime would go from a positive slope over here to a negative slope. So it would go from positive to negative, something like that, right?
Oh, and then y, it would
And then
just be a constant.
constant, yeah. So y double prime would be some constant below the x-axis. That doesn't, yeah, that's just a brief overview of that kind of stuff. Mr. Shah will go more in depth, probably like, let's say, all the way in January. So don't sweat that too much. Actually, probably not January, more like before the semester ends. So like maybe, I don't know, not even October, probably November. But yeah. Okay. any last questions on whatever you guys are gonna have a test on?
I had something like completely unrelated, right? So one day in class, Mr. Shah was talking about like how we're gonna have like a theory final.
Mm-hmm.
Like,
And
okay,
this is
so
your.
like,
Oh well, you just keep going.
yeah, like what is a theory final? Like everything that you've learned so far, like.
So you know how I showed you guys about derivatives and why we need to take them with respect to a variable.
Yeah.
So the theory final will test your understanding of that kind of stuff. So you know the question Shrieker showed you with the chain rule, using the chain rule to find. Remember that one?
Oh, the one that
you had to
implicit
cancel-
one.
The one where it was like cosine 3x and then x
Oh,
was
yeah.
yeah. So that would be like it wouldn't be the most challenging theory problem, but that's the kind of problems you get on theory where you have to actually know what a derivative is, why stuff works. So that's why I wanted to show you guys because you guys Shrieker kept coming up to me and Honors Chem and kept asking me questions, and Maud keeps texting me questions, and it feels like you guys don't actually understand like what a derivative is. You just say, hey, let's take how do I take the derivative of this? And there's no further context, though. Even though that further context is that's the heart of taking a derivative, is all that further context, not just taking the derivative. So that would be the kind of stuff on a theory test. This stuff too, where I'm talking about y and y prime and y double prime, that would probably be on a theory test. I know one popular problem here. Let me end on this problem. This problem's always fun. Let me see if I can remember it. So it's kind of hard to explain because you guys haven't gotten that far in calculus, but let me do my best. And this will give you an idea of what kind of stuff is going to be on the test. So let's say I have a graph, or let's not do this. Let's say I have f of x, or let's just use y, right? Let's say I have a function y. If y prime is some positive number and y double prime is some negative number, right? At some point x comma y, right? If I draw a tangent line at x comma y, it's kind of hard to explain because there's a lot of terms I'm supposed to be using, but you guys haven't learned it yet. But if I draw a tangent line at x comma y, and then I try and take okay, so let's say if I take the tangent line of x comma y, and then I have a point x plus 0.001, and then some number, right? And I take that and I find this value for both y and the tangent line. Will the tangent line overestimate or underestimate the value? The actual value.
So y prime is positive. Would it overestimate? Because technically the
Is
graph's
it y
going
prime
down.
at that point?
Yeah,
Y prime at that
y
point,
prime
right?
at this point. So at that point.
Wouldn't it be
And then,
overestimate because the graph is going down?
Yeah, it's not going down, but it's an overestimate because the graph would look kind of something like this. You see how the slopes here. You see how the slopes are positive all the way through? They're positive,
Yeah.
right?
yeah.
But the slopes are decreasing. The slope went from this really steep positive to like kind of a steep to less steep. So it's decreasing. The slope values are decreasing. So let's say I draw this tangent line. Let's say there's this point x comma y, and I draw this tangent line over here. And then see how every point after it is underneath our tangent line?
So then
it's
it would
underneath. It's
overestimate.
underneath the curve. Like,
Yeah.
Okay.
So it's overestimating. So that's the kind of stuff on a theory problem. You have to actually understand what y prime and y double prime are. You can't just know how to take a derivative.
Are you like allowed to draw those graphs or like?
Yeah, you are.
Okay.
So yeah, okay. I can do one last question if you guys have one. If not, we can end it. Is everyone good?
I'm good.
Yeah.
Okay, cool. All right. Next, so I'll be doing these on Discord from now on, and yeah. So next week I'll probably do one more, probably around the same time next Sunday. So yeah. All right. Bye.